have 95% CO2 selectivity. So N4, which is the amount of CO2 formed, is going to be equal to, so we have, let me just show you here. So we have 75 moles of methane entering the process, and then we have 7.5 moles leaving the process. So that means 67.5 moles of methane react in the process. And of the methane that reacts, 95% of it reacts to form CO2. And 1 mole of CO2 is generated per mole of CH4 that reacts. So that's just the stoichiometry. So that gives us that we have 64.125 moles of CO2 formed. And we can do the same thing for CO, because we know that there's a 5% CO selectivity. So N5 is going to be equal to 0.05 of the 67.5 moles of CH4 that reacts. And then there's 1 mole of CO generated per 1 mole of CH4 that reacts. And that gives us that there's 3.375 moles of CO formed, and that's N5. And then now for N6, what we're actually going to do is we're going to do a hydrogen balance. So we're going to have 75 moles of CH4, 4 moles of hydrogen CH4, plus 25 moles of H2, 2 moles of hydrogen in each H2, and that's going to be equal to, let's see, N2 is 7.5 times 4 plus N3, which is 3.75 times 2 plus N6 times 2. And when we algebra that out, we end up getting that N6 is equal to 156.25 moles of H2O. Now we're going to do an oxygen balance to get N7, which is the moles of O2 that are left over in the process, unreacted. Non-O2 balance and oxygen balance. So we have that 0.21 of the 967.263 moles of air fed times 2 moles of oxygen per mole of O2 is going to be equal to, let's see, N4 is 64.125. And there's 2 moles of oxygen, CO2, plus N5 times 1, plus N6, which is 156.25 times 1, so I'm not going to include that. And then plus N7 times 2. And that ends up giving us that N7 is equal to 59.19 moles of O2. And finally, we're going to figure out N8 by doing a nitrogen balance. And nitrogen's non-reacting, so this isn't like really part of like atomic species method here. It's just like we are figuring out N8 is just equal to 0.79 times N1. So N8 is going to be equal to 0.79 times N1, which is 967.263. So 764.14 moles of N2 is equal to N8. And now what we can do is figure out the total moles of exit gas. And that's just going to be N2 plus N3 plus N4 plus N5, N6, N7, N8. And that ends up giving us 1058.33 moles total. So now to calculate the concentration of CO in the exit gas, we have that there's 3.375 moles of CO exiting, and then 1,058.33 moles total. And to convert from this composition to ppm, what you would just do is multiply by 10 to the 6, and that ends up giving us about 3190 ppm, which is parts per million. So per 1 million parts of volume, only 3,000 of those are taken up by carbon monoxide.